Welcome to this deep dive brought to you by CBSE ScoreLab of ProfSam.com.
Hello, everyone.
Today we are exploring the very foundation of Unit 8, electromagnetic waves.
A fascinating topic.
It really is. And our mission today is to unpack this core concept, how light and radio waves even exist, and to make that fundamental connection between electric and magnetic fields crystal clear for you.
And of course, completely exam ready.
Absolutely. So let's start with a question that really puzzled scientists for centuries, and maybe it's something you've wondered about too.
Okay, I'm listening.
We know from our everyday experience that sound needs a medium. It needs air or water, something physical to travel through.
Right, you can't hear a sound in a vacuum. That's a classic experiment.
Exactly. If you shout in space, as they
Yeah.
say, nobody can hear you. So, how does light from the sun manage it?
Manage what?
To travel 150 million kilometers through the completely empty vacuum of space to reach us here on Earth.
That's a phenomenal question.
There is nothing physical to vibrate out there. So what exactly is the thing that is moving, and how does it carry so much energy without any medium at all?
If space is a void, then light must be something. Well, something radically different from a sound wave. If it is a wave, then what is actually doing the waving?
And here is the surprising answer that really unifies a huge part of physics. The visible light that lets you see, the heat you can feel from a fire from far away, and the radio signal that keeps your phone connected.
Yes.
They are all fundamentally the exact same phenomenon.
Wait, really? The same thing?
Yes, they are all electromagnetic waves. They are all made of the same stuff and travel at the same constant speed.
So light and radio and heat. They're just different versions of one another.
Precisely. The only difference is how rapidly they oscillate, their frequency. Understanding this unified view that light and radio are inseparable, that's the central aha moment of this entire unit.
Okay, that's a big idea.
It is. So let's unpack this core idea. Before the 1860s, electricity and magnetism were seen as completely separate forces.
We studied them in separate chapters, after all.
We did, but the great physicist James Clerk Maxwell showed us that electric fields, which we call E, and magnetic fields B, are not separate at all.
Yep.
They are two interdependent aspects of a single unified electromagnetic phenomenon.
So they're sort of fixed together.
Intimately, yes. They are continuously connected by a very simple rule. A changing electric field generates a magnetic field.
And I'm guessing a changing magnetic field generates an electric field.
You've got it. That reciprocal action is what allows them to propagate themselves, to travel.
Okay.
Think of our primary analogy here, the two dancers in sync.
The two dancers.
Imagine the electric field is one dancer moving vertically up and down, and the magnetic field is the second dancer moving horizontally side to side.
Okay, I can picture that.
Now imagine they are linked by an invisible, unbreakable thread. That thread is the laws of physics.
So when the E dancer moves up, it forces the B dancer to move sideways and then the other way around.
Precisely. Whenever the E field changes its strength or direction, that change automatically creates a magnetic field.
Right.
And crucially, that new magnetic field is also changing, which in turn automatically creates a new electric field. And this just keeps the whole oscillation going.
So it's a continuous, synchronized energy exchange.
Yeah.
That's what the wave is.
That is the wave. That's what moves through space.
I understand the synchronization part. The dancer analogy helps. But this connection still feels a little unbalanced, doesn't it?
How so?
Well, we spent a whole unit on Faraday's law. It told us very clearly that a changing magnetic field induces an electric field. We get that.
Yes.
But why did Maxwell just decide that a changing electric field must also create a magnetic field? Where did this symmetry idea come from?
Now that is where the genius lies, and where the history gets really interesting. When Maxwell was compiling all the known laws of electricity and magnetism, he found a mathematical hole, an inconsistency.
In the existing laws.
Yes. He looked at something called Ampere's circuital law. Basically, it describes how electric currents create magnetic fields.
I remember that.
But when he applied it to a charging capacitor, he found a problem. There's a current flowing into the plate, but in the empty gap between the plates.
There's no current, no charge is flowing through the gap.
Exactly. But a magnetic field was still being created as if there was a current. The law was mathematically incomplete. It broke down.
So the maths didn't work in situations where fields were changing, but charges weren't actually moving through the space.
That is the exact flaw he found. He realized the whole system needed symmetry. If a changing B creates an E, as Faraday showed,
Then symmetry demands that a changing E must also create a B.
exactly. To fix the maths, he introduced a new theoretical term. He called it the displacement current.
Displacement current.
This is the crucial insight. It's not a flow of charge. It is the effect of a changing electric field, an effect that creates a magnetic field just like a real current would.
So it's like a phantom current.
In a way, yes. This conceptual leap completed the unified theory. It made the whole self-propagation mechanism possible.
Wow. Okay.
Now, let's lock in a powerful visual image. Picture empty space as a calm, infinitely deep sea.
Okay.
Now imagine a disturbance, a vertical force, starts at one point. That's our oscillating E field. As it oscillates up and down, it generates a magnetic swirl, the B field, around it.
And the fields themselves are the disturbance. They aren't vibrating some water.
Perfect. The E disturbance pulls B along, which in turn ensures E continues, and that whole pattern moves outward, away from the source. The source just starts the dance, but the partners, E and B, keep pulling each other forward across the vast, empty ocean of space.
At a constant speed.
At a very specific constant speed. Now let's see how NSERT formally defines this concept. Could you please read the definition for us?
Of course. The text states, electromagnetic waves, which are coupled, time-varying electric and magnetic fields that propagate in space.
Excellent. The keywords there for any exam are coupled and time-varying.
Coupled and time-varying.
The fact that they are time-varying means we need an initiating source, and that source is always an accelerating or oscillating charge.
Right. So a static charge just gives a static E field. A charge moving at a constant velocity gives a steady B field.
Yes.
But only an accelerating charge can produce these time-varying fields that can then go off on their own.
That is a perfect summary. Now, let's trace the propagation step by step with Maxwell's complete vision. 1. The accelerating charge creates an intense, rapidly changing E field. 2. This changing E field acts as a displacement current, and it generates a time-varying B field in the space around it.
Right, the new part Maxwell added.
3. This new time-varying B field by Faraday's law regenerates the E field. And 4, this cycle E creating B, which creates E, means the disturbance moves outward. It becomes self-sustaining.
And it no longer needs the original charge.
It doesn't. It's on its own. And this led to the most spectacular result of Maxwell's work. When he combined all 4 fundamental equations of electromagnetism, he was able to mathematically derive the speed of this wave.
He calculated it from theory.
Just from theory. He found that the speed, which we call c, was determined entirely by 2 constants that were already known from completely separate experiments.
What were they?
The magnetic permeability, mu0, and the electric permittivity, epsilon0, of free space. The formula was c equals 1 over the square root of their product.
And when he calculated the value...
Here's the mic drop moment. The result was almost exactly 3 × 10 to the power of 8 meters per second.
Wow. That's the speed of light.
That was the measured speed of light. At that moment, the equations proved mathematically that light must be an electromagnetic wave. It unified optics and electromagnetism forever.
That is incredible.
Hope everything is clear so far. This concept explainer is from ProfSam.com. That is ProfSam.com.
Okay, that makes a lot of sense.
Now let's quickly do one very simple calculation to understand the physical relationship between the 2 fields. The ratio between the amplitudes, or the peak strengths, of the electric field E0 and the magnetic field B0 is fixed. It's given by E0 divided by B0 equals c, the speed of light.
Okay, E0 by B0 is c.
So let's imagine a strong electromagnetic wave. Let's say the peak electric field amplitude, E0, is 6.3 volts per meter.
And we know c is 3 × 10 to the power 8 meters per second.
Correct. So to find the magnetic field amplitude B0, we just rearrange the formula. B0 equals E0 divided by c.
So that would be 6.3 divided by 3 × 10 to the power 8.
Yes, and that gives us 2.1 × 10 to the power of -8 Tesla.
10 to the power of -8. That's an extremely small number. Even the Earth's magnetic field is much stronger than that.
Absolutely. The calculation shows that in a typical light wave, the magnetic component is tiny compared to the electric component. This is why when light interacts with matter, it's usually the effect of the electric field that dominates.
I see. So the E field does most of the work.
Generally, yes. It just reinforces this fixed quantifiable link between the two. And this powerful framework means we can now describe any EM wave by its frequency, f, and wavelength, lambda, linked by that one constant speed, c equals f lambda.
And that's what leads into the whole electromagnetic spectrum.
Exactly. Radio, microwaves, light, X-rays, all on one continuous spectrum. Now, let's talk about the silent killers.
The exam misconceptions.
The subtle points where our intuition can lead us astray and cost us marks. Misconception number 1, the medium requirement. So many students, because they are used to sound waves, think EM waves must need a physical medium.
It's a natural assumption to make because we're used to things moving through something.
It is. But the correct idea is that EM waves are oscillations of the fields themselves. They require no material medium at all. In fact, they travel fastest in a perfect vacuum.
So the thing to remember is...
EM waves are the disturbance, not disturbances of something.
Got it. What's the second one?
Misconception number 2, which is crucial for drawing diagrams. Geometry. Students sometimes think the E and B fields are parallel to each other.
Or maybe they think the fields oscillate back and forth along the direction of travel.
Which would make it a longitudinal wave, like sound, but that is also incorrect. The correct idea is that the E and B fields are mutually perpendicular to each other.
Okay, so they are at 90 degrees to each other.
And D, both of them are perpendicular to the direction the wave is propagating. This three-way 90-degree relationship is fundamental. It's a transverse wave.
So for absolute exam safety, I must remember, electric field, magnetic field, and the direction of wave travel are always 3 mutually perpendicular vectors, like the x, y, and z axes on a graph.
Exactly right. That visualization is key. And to make sure you remember this concept for life, let's use some memory anchors.
Okay.
A simple mnemonic. Remember that E and B are eternally bonded, but essentially perpendicular.
Eternally bonded is essentially perpendicular. I like that.
It captures both the relationship and the geometry. Now, for the physical gesture, this works every time. Hold your right hand up.
Okay.
Point your index finger straight up. That's the E field. Now point your middle finger straight forward at a right angle to your index finger. That's the B field.
Okay, got it. E up, B forward.
Now stick your thumb out to the side. That's the direction of propagation. CE is perpendicular to B, and both are perpendicular to C. Now you can wiggle your fingers to remember they oscillate, while the whole hand moves in the direction of the thumb.
That physically locks it in. The transverse nature. E, perpendicular to B, and both perpendicular to C.
That is the image you must carry into the exam hall.
Okay.
Right. Let's quickly summarize the 3 core exam-safe factual points about the introduction to EM waves.
The 3 main takeaways.
First, electromagnetic waves are self-sustaining, synchronized oscillations of perpendicular electric and magnetic fields.
Okay.
Second, they are produced by accelerating or oscillating charges, and they travel at the speed of light, c, in a vacuum. And third, all forms of radiation, from radio waves to X-rays, are fundamentally the same thing. Electromagnetic waves differing only in their frequency and wavelength.
Perfect. Clear and concise.
To get maximum marks in 12th CBSE physics, chemistry, and maths, visit ProfSam.com.
That is ProfSam.com, right?
Yes. Thank you for joining us for this deep dive into the existence and nature of electromagnetic waves. Keep learning and keep asking questions.
Thank you.